The internet pretty much feels like magic, right? But it's not. It runs on actual physical hardware. And right now, the very foundation of how our mobile networks are built is going through this quiet but absolutely massive revolution. So let's dive in and break down what's really happening. You see these cell towers literally everywhere. They're the physical link between the phone in your hand and, well, the entire world. And for decades, the tech packed inside them has been built in a very specific, kind of closed off way. But that's all changing, and the results could make our networks way faster, cheaper, and a lot more innovative.
All right, so to really get a handle on where we're going, we first have to understand where we've been. Let's take a look at the old way of doing things, the closed traditional network.
Okay, so at the heart of all this is something called the RAN, which stands for Radio Access Network. It's actually a really simple idea. This is all the gear that uses radio waves to connect your phone or any device to the rest of the internet. It's literally the radio part of the network. The best way to think about the old traditional RAN is to compare it to buying a pre-built computer from one of the big brands. You get the whole thing in one box from one company. The parts inside, they're all designed to work only with each other using their own special connections. You can't just pop it open and swap out the graphics card for a better one from a competitor. This whole situation is called vendor lock-in, and for the longest time, this is exactly how mobile networks were put together. And look, this one-size-fits-all model, it worked fine for a while. But then, 5G came along, and the huge leap in performance that 5G promised put an incredible amount of strain on this old, rigid system. It just wasn't enough anymore.
All of a sudden, network operators needed these massive increases in speed and capacity. They needed to be way more flexible to offer all the cool new services 5G enables. But with the old model, they were stuck. They had these long, slow update cycles for their hardware, and they couldn't just pick and choose the best piece of equipment for a specific job. They were locked in.
So engineers tried to get clever. They thought, hey, instead of having all the computing power at the base of every single tower, let's try to pool it all together in a central hub. They called this centralized RAN, or CRAN. It was a great idea in theory, but it immediately slammed into a wall, a physical limitation that was measured in just a few microseconds.
Yup, this was the problem, a super strict delay requirement. The round-trip signal time between the radio on the tower and the central processing hub couldn't be more than 100 microseconds. I mean, that is an unbelievably short amount of time, and it meant that the central hub couldn't be very far from the tower at all.
This created a situation that's actually pretty easy to imagine. Think about buying a brand new computer monitor, but it comes with a cable that's only 3 inches long. I mean, sure, it technically works, but it completely dictates where you can put everything. That 100 microsecond limit, that was the network's 3-inch cable. They needed a whole new approach. And that new approach was, honestly, just genius in its simplicity. Instead of trying to connect one giant monolithic box, they asked, what if we just split that box into smaller, more specialized pieces? So first, they came up with the Central Unit, or CU. You can think of this as the high-level brain of the operation. It handles all the tasks that aren't super sensitive to delay. The big picture stuff, like managing resources and routing traffic where it needs to go. Next up is the Distributed Unit, or DU. Now this piece is crucial. It sits closer to the tower, and it handles all the real-time, delay-sensitive stuff, like scheduling the little packets of data for transmission. It deals with everything that has to happen right now. And finally, that brings us to the radio unit, or RU. This is the part that's actually on the tower itself. Its job is simple but absolutely essential. It takes the digital ones and zeros from the DU and turns them into radio waves to send to your phone. And of course, does the reverse for signals coming back. And this split, breaking that one big box into the CU, the DU, and the RU, that was the key that unlocked the whole thing. It's what paved the way for the real revolution here. Open RAN. Now, this didn't just happen overnight. The path to real openness had 3 key steps. First, you've got this split RAN, which we just talked about. Then came vRAN, or virtualized RAN. This was about separating the specialized software from the specialized hardware, which meant you could run network functions on more generic, off-the-shelf computers. But the final and most important step was ORAN, or Open RAN. This created standardized, open connections between all those different parts. And this brings us right back to our computer analogy. Open RAN is basically like building a custom PC. Because all the connections are standardized,
think USB or HDMI, a network operator can now buy a central unit from one company, a distributed unit from a completely different one, and a radio unit from a third. They can mix and match to choose the absolute best-in-class gear for every single part of their network, and that just lights a fire under competition and innovation.
So, okay, this is a really fascinating bit of engineering, but why should you care? What does it all mean for you? Well, it turns out this open future has some real, tangible benefits for all of us. Well, for starters, an open ecosystem means way more competition, and that drives down costs for the network operators. It also lets smaller, more innovative companies jump into the game and create brand new solutions. It all adds up to a faster rollout of 5G and whatever comes next, and ultimately a more flexible, modern, and secure internet for every single one of us. In the end, what Open RAN is really about is moving away from a closed-off, one-size-fits-all world and embracing an open, modular one. And it leaves us with this incredible question to think about. When you break down the walls and open up a system to more builders, more creators, more innovators, what amazing new possibilities are they going to build that we can't even imagine yet?